Hello everyone, welcome back. So now to a slightly harder problem. Once again, this is a group problem solving, so I guess we're solving it in a group or doing it together. But I can't hear your examples or your help. So try to find a friend and see if you can do it with them. If you live with your parents, ask them to help you. You can teach them. Honestly, the best way to learn is by teaching. So pick anybody. Try to teach them, see if you can solve the problem using them or showing them how to solve the problem. I guarantee you'll learn this better. So what is our problem actually talking about? Well, if we look at this, we have a flagpole. It's got two lines that are holding it down with a force of FB and FC. It's 560 newtons and 700 newtons respectively. And it wants us to find the magnitude and the coordinate direction angles of the resultant force. Okay, so what are we going to have to do? Well, we're going to have to find two position vectors here. From AB and AC, and use those to figure out what the force vector is going to be. We'll get those force vectors in Cartesian vector form. We'll add all the forces together to get the resultant force, and then we'll use the magnitude to get the coordinate angles of the resultant force. So, with that in mind, pause. Go try it on your own. See if you can do it. Give it a good 10-15 minutes. It's a little bit longer problem. And once you try it on your own, come back, see the rest of this video. So, 3, 2, 1. Okay, hopefully you've unpaused now, you're press play, and you're going to finish the rest of this. So, with that in mind, let's jump into it. I forgot to click me. There we go. So first off, we need to get a position vector for AB and AC. Now, there's a bunch of ways you could do this. Since these forces are concurrent, it means they happen at the same point. We can kind of forget the whole tip minus tail thing, and we don't have to just find where this tail is exactly. Like as you saw, if you didn't look at the previous example video, I can, if I want to, write out a position vector from the origin, which is right here. First to here, and then to here, and subtract them to get that. I can do that. That's completely fine. However, that's really unnecessary for concurrent forces. When we have forces, when we're actually having a bar or something that has size, then we have to worry about where they began. In this case, we can just say, well, what's the change from A to B? How am I moving? What you can see is, well, from A to B, I went down 6. I went over 2, and then over 3. That's it. Sorry, that was from A to C. For A to B, I go down 6 still. I go in the negative y direction 3, and I go in the x direction 2. So with that, you can solve it pretty quickly. And that's probably how they did it right here. They didn't write it out. They could have written out position vector if they wanted to. But instead, they just said, well, what's the change? And you can look at it visually and see that. Just be very careful because as you saw, I got confused. I mixed up my C and my B. That happens. So if you want to be absolutely safe, write out the coordinates from this point to each of your points and then subtract them. Remember, this is the tail, that's the tip. You take the tip and you subtract it from, you take the tail and you subtract it from the tip. I always want to get that wrong. I promise you, I know how to do it, I just always want to say it wrong. Okay, now what is the magnitude of these two position vectors? Well, luckily they're the same exact length. You could kind of guess that 2, 3, 6, 2, 3, 6. And the magnitude happens to be 7. Hey, I feel like they set that up for us to make it nice. Go and thank a book writer today. Now, how do we get the unit vector from this? Well, it's fairly simple. We just divide everything by that unit vector. And then just to skip a step, because this right here is the unit vector, I don't actually need to calculate it fully right this second. I can just multiply everything out. So this would be for the force vector AB, and the second one is for the force vector AC. I'm just taking the magnitude of that force vector. That right there is force AB, not in bold, not in red. It's hard to see. Like normally, if you can't write bold and red, use a little hat like that. It shows it's a vector. We can't do that at the moment. So just know that this right here is a scalar. This is the vector. Okay. So we do the same thing for both of them. We get our position vector, we divide by the magnitude to get our unit vector, and then we multiply by the magnitude of our force vector to figure out what our force vector is in Cartesian form. We do it for both of them. Now to get the resultant, it's not hard. We just have to add both of those together. So we do that. We add both of those vectors together, and what we get is this. And then finally, the last thing it asked us for is what's the magnitude and what are our direction cosines. So you're like, oh goodness, I gotta figure out those angles. Actually, it says what was our coordinate angles, not direction cosines. You actually need to know the angles if you just want the direction cosines. So the way we solve for that is first we take the magnitude, which is just you take each of the components, you square them, and you add them all together, and then you take the square root. It is, in this case, it's like z squared, too high. Z squared is equal to a squared plus b squared plus c squared, where z is the length of your line. So it's just like Pythagorean theorem, just for 3 dimensions. Then to get our direction cosines, remember that cosine of theta, or cosine of alpha, beta, gamma, is going to be equal to each component of your unit vector. So if you take inverse of cosine of each component of your unit vector, then you get alpha, beta, or gamma. And just to write that out, so we have our unit vector. I'm just going to say u resultant. It looks something like this. It'll be cosine alpha I plus cosine beta j plus, way too high now, cosine gamma k. And so we're taking the inverse cosine of each of these components in order to get alpha, beta, and gamma. And that's what we have right here. So we solve for all of them. And if you're wondering, like, wait a second, this is more than 90. Is that wrong? It's not. It can go from 0 to 180. So as long as you don't have anything greater than 180, you're fine. Okay, so that should be everything. We've solved the problem. Well done. Now, I know we went a little bit fast, but these direction cosines, they are extremely important. Remember these things. Remember that you just get them from your unit vector. And if you already know them, it's super easy to calculate your unit vector. So that's going to be helping you a lot. I'm trying to make sure you realize that now, because later on in the class, there's going to be some problems where you run into it and you're like, how do I do this? It's all going to come down to your direction cosines. Okay, well, I'll see all of you later. Hope you enjoyed this. Have a great day. Bye-bye.